Hi everyone, welcome back. Welcome back to System Verilog Assertion series. So in today's video, we are going to talk about some of the operators within System Verilog. Like in the previous session, we have already discussed about how we are going to write some of the assertions by using some of the operators like logical operators, and also how we have already discussed about how we will be using a delay in the sequences, right? So in today's video we are going to talk about implication operator. In yesterday's video we have talked about this assertion series, like in sequence how we are going to use the delays and how we are going to use the operators like logical operator, like AND operator or operator. So all these things we have discussed. If you didn't see that video, I'll link that video in the description box. You can go there and check it out. And so we have talked about only sequences more, and we have already explained that with an example. Okay, on the EDA playground we have checked like how the assertion failure, you can detect the assertion failure in the code actually, right? So please check that video so that you can understand how actually we can check the assertion failure. If you are a fresher or beginner to this System Verilog course, then you should know how to detect the System Verilog assertion failures, right? So please check that video if you didn't see that, and then come to this video. I'll link that video in the description box, as well as I'll mention it in the top of this video. You can go there and check it out, right? And we have talked more about sequences, but we didn't see more about the properties and System Verilog assertion. So in today's video we are going to talk about the properties within the concurrent assertions, because as you already know that we'll combine a group of sequences into a property so that we can easily assert the single property instead of asserting all the sequences individually. So yes, in yesterday's we have talked about how we insert the delays in sequences, and we are having operator called implication operator, which is used on properties only. Okay, so we can assert property, like we can insert the delays and we can insert the operators within the properties also by using this implication operator. I think you have already seen this implication operator while we are talking about the OOPS concepts. So, yes, implication operator is basically denoted by this symbol, a dash and arrow. It's just like an arrow symbol. Okay, so in System Verilog assertions, you are having two types of implications. One is overlapped implication, another one is non-overlapped implication. So, what is the difference between this overlapped and non-overlapped implication? We are going to see this today in detail. So, for example, if this is a sequence, as if you see, this is the sequence a hash hash to B. So what is the meaning of this sentence? After A is high, then after 2 clock cycles of time B should be high. So this is the meaning of this particular sequence. For every passage of clock, after A is high, then after 2 clock cycles B should be high. So this is my condition for this particular two signals. Now if you are writing only one sequence, then it is fine. Similarly, if you are writing some two or three sequences, and now you should know which sequence to be executed first and that means which sequence condition should be checked first and which sequence condition should be checked next. So in this way, if you want to follow the order for your sequences, then it is possible by using the implication operator. Okay, so in implication operator, basically just like implication operator is very similar to this particular logical operators and all. Okay, so similarly, just like you are having two input signals A and B, similarly in implication operator also you are having two signals. So the left hand side signal is called antecedent and the right hand side signal is called consequent. So basically the left hand side signal will be executed first. So after the left hand side signal is executed, then only the right hand side signal will be executed. So basically after this happens, then this happens. So that is the meaning of this arrow signal. That means after antecedent execution, that means after checking the antecedent signals, then the consequence signal takes place. That means then this is evaluated. First the evaluation is done on antecedent, and then the consequent evaluation will be done. So this is the meaning of this implication operator, right? So basically here you are having again in this like if you see here within this evaluation, like antecedent and after consequent, also you are having two kinds, like overlapped implication and non-overlapped implication. Basically the overlapped implication and non-overlap, how can you detect the difference between these two things is by using the symbol. Okay, and also one important thing that you should remember is this implication constructed can only be used in the property definitions only. You can't use this in the sequences. You can just use this implication operator in the property itself. So let us see what is this overlapped and non-overlapped. So basically overlapped is denoted by this symbol. Okay, so dash and this one. Okay, but non-overlapped means it will be in this way. So double equal to symbol with an arrow. Okay, so this is, don't get confused, this is non-overlapped and this is overlapped. So let us see now what is the difference between this overlapped and non-overlapped. Okay, you can just pause this video and just study this, but I want to give you an example for this in a picture format so that you can easily remember it very easily. So let us see this particular property. So in this property, for every positive edge of the clock, so what is the property? Valid. So this is my antecedent, and this is the equation a hash 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 double hash 3 and b. So this is my consequent, and if you see here, this is the implication operator. So what you know according to implication operator, after antecedent is evaluated, then the consequent should be evaluated. So this is fine, right? Now if you see this, this is the if you see this, this is the overlapped implicator. So what it should happen means, for every passage of clock the checking will be done, right? For every passage of clock after valid is 1, that means after valid is high, in the same clock cycle this consequent should also happen. That means if you see here in this clock cycle, in the first clock cycle valid is low, so assertion is failed, and in the second clock cycle valid is high. So as soon as the valid is high within the same clock cycle, the particular consequent logic, like a star star b, this also should be high. That means a should be high, and after a is high, according to this logic, after a is high, after 3 clock cycles b should be high. So after 3 clock cycles b will be high. Clear? So in this way, within the same clock cycle, both antecedent and consequent should happen. Okay, so this is the overlapped implication. That means one assertion is overlapped, antecedent is overlapped on consequent. So clear? So this is about the overlapped. The entire opposite is non-overlap. So what is the overlap? Actually you have seen. Now if you see the same condition, but this is the non-overlapped assertion. So what happens here? After, at the first clock cycle valid is 0, so assertion is failed. In the second clock cycle the valid is high. So since the valid is high, then the second equation, that means a should be high after the next clock cycle of valid. That means in the first clock cycle if valid is high, then in the next clock cycle a should be high. Okay, then after this, after 3 clock cycles, the particular b should be high. Clear? So in this way this is non-overlapped. That means after first antecedent happened, after first antecedent is evaluated, then in the next clock cycle the next consequence should happen. Okay, so this is the non-overlapped implication operator. So basically you are having two implication operators, which is overlapped and non-overlapped. So you have to check while you are writing if there are conditions. For example, if you were asked to write a condition where as soon as the antecedent, like if in the property if you are asked to check whether two sequences are happening at the same time, or whether after first sequence is happening then the second sequence should happen, if you are given a condition like that, so by using this overlapped and non-overlapped implication operators you can check it very easily. You can write the assertion very easily by using this implication operators. Clear? Hope you got an idea on what is implication and non-implication implication operator in the property. Again, in this implication and non-implication operators also, just in the previous session we have discussed how we will be inserting the delays within the sequences. Just like that, within this particular implication operators in the property also you can insert the delays, because if you see here in the now you may get a doubt that since if we can use this non-implication operator like non-overlapped operator, the delay will be happening. Yes, the delay will be happening, but it is only for one clock cycle of delay. Yes, is it or not? But if you want the second consequent to evaluate after some particular period of time, after some clock cycles, then you should insert the delays. Okay, so for example, if you see this operator A overlapped implication B and you are giving the delay. If you have not given this delay, then what happens? Within the same passage of clock, after A is high, then immediately B will be high. But you don't want that condition to happen. What is the thing that you want to check? After A is high, then after 2 clock cycles B should be high. So now what happens? Instead of using the writing it just using, if you are using the non-overlapped operator, only one clock cycle will be delayed. But if you want more number of clock cycles for your B condition to be applied, then you can just use this hash 2. This is the, you already know that this hash is related to delays. I have already explained it clearly in the previous session while we are discussing about the concurrent assertions. As I told you, I'll link that in the description box. You can go there and check it out. So the same thing, this is how you will be writing by using the implication operator within the properties. But if you are writing within the sequence, you can just write it as A hash to B. Okay, so this is how you will be writing your sequence and properties. Now let us see how we are going to use it actually in real time while you are writing the codes within the developing the codes in test wins. Okay, for example, these are the two sequences I am writing. So this is my sequence 1 where the logic is A and B hash 1 C. That means after this logic is happened, then after one clock cycle of delay, then C should happen. C signal should takes place. Then within the sequence 2, what I am writing after C, that means after this particular sequence or this particular sequence is based on the property. So here actually according to property, first sequence 1 should happen, then sequence 2 should happen. Now that means after A is 1, then B should be 1, because both should be 1. After these A and B are high, then only C should be high. That means after A and B both are in high condition, then after one clock cycle C should be high. Okay, so for example, if it is at one clock cycle, then after 1 plus 1 2 clock cycles, this C should be high. Okay, so this is the condition. Now after this, that means after C is high, after this sequence is happened, then the second sequence should be evaluated. So what is the second sequence? After C is high. So if you see here, I didn't have any other condition. I have just mentioned the delay and not of 2. That means after C is high, then after 2 clock cycles of time, what should be? D should be not high, but it is not D, so D should be 0. So this is the condition I want. That means I want it as 1 1 and 1 and 0. So this is my condition. That means A and B both should be high, then after one clock cycle of delay C should be high, then after 2 clock cycles of delay D should be 0. So this is my condition. So I have inserted everything within the two sequences, and now what I am doing, I am writing the property where for every passage of clock, what I am doing, I am just checking these two sequences. So since this is an implication operator, that two overlapped implication operator, then what happens? Sequence 1, as soon as the sequence 1, that means as soon as A and B hash 1 C happens, then in that case immediately the next one, if since I have given delay here for 2 time units, so after C is high, after 2 clock cycles D will be 0. But if I didn't mention any of this delay, then what happens? As soon as the C is high, in that same clock cycle the D will also be 0. Okay, so this is the implication operator. Clear? So this is how you will be writing the implication operators within the this is how you will be writing the assertions within your system verilog codes while you are developing the test benches. Okay, so similarly, just like you have used the time delays within the sequences, you will be using the same within this particular properties also. If you see here, it is within the range. That means after A is high, then within 1 to 4 clock cycles B should be high. Okay, here everything is same, because if you see here, mostly the time delays is everything same, but here if you see, this is the range. That means within 1 to 4 B should be high, and here if you see, this is the it should be between A should be high on given percentage, then B is high in the same clock cycle or within 4 clock cycles. Because here I have mentioned it as 0 to 4, so it is either within that clock cycle or from 1 to 4, within any of the 4 clock cycles the B will be high. Okay, now if I am not mentioning it is anything, like if you see here 1 to dollar, so dollar denotes that until and unless there is until and unless this simulation is happening, at any point of time after A is high, the B can be high. If at any point of time if B is high, after as soon as the A is high, then immediately you can say it as an assertion. The assertion has passed. Okay, if you don't want to give any time limit for the another sequence, then you can be writing it in this manner. Okay, now the same thing for repetition. We have seen this repetition operators within the sequences also. The same goes with this properties also. I don't want to repeat again, because I have already explained it clearly in the previous session. You can just pause this and you can just check this writing, so that you will understand. And if you didn't understand, you can ping me in the comment box. I'll definitely answer all your questions. Right? So these are the sequences, these are the properties and sequences that we have explained in this video, and in the next upcoming videos we will be seeing about system verilog assertion methods. Like we are having 4 types of methods important, which are very important in system verilog assertions, because basically when you were asked to write an assertion, basically you were given a logic and you were asked to write an assertion. And if not that is the question, then the most questions arise from these 3 4 concepts, like what is dollar rose, what is dollar fell, what is dollar stable, and what is dollar past. Okay, you should know about this SVE assertion methods in order to clearly understand, because every time we don't need to mention this overlapped and non-overlapped implications for doing those simple work. So basically these are some inbuilt system functions where you can directly call it and you can use it instead of writing the entire delay process for these assertions. Right? So we'll be seeing in the upcoming video, and if you like this video, please do like it and also share it to all the VLSI aspirants, and also please do subscribe to my channel VLSI to you. And that is all for today. Thank you all.